Hi guys, in this video our objectives are describe the behavior of y equals fx using derivatives. So we will use this one to determine whether our function is increasing, decreasing, and stationary. The second objective is find the second derivative and use this one to determine what's the concavity or the opening of the graph. Is it open upward or downward, or is it a point of inflection? And we will also discuss how to use this one to determine the nature of your stationary points. And the last one is the first derivative test. So let's begin. Suppose I have this function. So I gave you in your, what do you call this one? I gave you in your mathematical investigation. Suppose that you have your y is equal to x cubed minus 2x squared minus x plus 2. So if you remember mathematical investigation, I gave you this function and then I asked you to draw it. So this is the graph of that. So that is the graph of the function. And then I asked you to give me the derivative of this. When we look at the dy dx of that, it will give you 3x squared minus 4x minus 1. And then it asks you further to find the second derivative of this one, wherein the second derivative is 6x minus 4. So this is the first derivative and this is the second derivative. Take a look at the symbol. It's second derivative of y with respect to your x. Now, on the second part of the mathematical investigation that I gave you, I asked you to plot this 2 into the same Cartesian plane. So when you graph, for example, the first derivative and the function, so you have it here. So the red one is your y, while the blue one is your y prime, or your first derivative. And let's try to look at what's going on. What's going on here? Now, first of all, let's try to look at here. So, from this negative infinity up to here, as you can see, up to this point here, as you can see, this portion here, the curve is increasing. So it is increasing. It is going up. Alright? While this portion from here, from this top one up to here, so that one is decreasing. So this portion is decreasing. Decreasing. While after this point, as it goes up there again, so this one is your increasing. Okay, so you have increasing, up, decreasing, then up, then you have increasing. But what is something good here is that these green points here, these 2 points here, this is the point where it changes from increasing, it changes up to decreasing. So that is what we call, this specific point is what we call as stationary points. Okay, they're stationary, they're not moving. Here, this is also stationary. Or in short, the stationary point is actually the lowest point on the curve. Right? The lowest. So it's either this one and that is that one. Now, let us try to describe this behavior by trying to look at to the graph of the first derivative. So when you look at the graph of the first derivative, you will have this one here. You need to look at the blue one here. So that's the graph of your first derivative. Now, let us try to look at this part of the first derivative, this portion here, this portion. As you can see, at least this part here, that is actually above your y-axis, or sorry, above your x-axis. So from here to there, it is above the x-axis. What does it mean is that here, the derivative here is greater than 0 because it is above this. So here, I want you to look at this part here. So here, the dy dx on this line is equal to 0 on this line. Above that one, so the dy dx is greater than 0 because it is above that x-axis there. As you go down here, your dy dx is less than 0. So this below here, the below portion of the graph, of the blue graph, that is your dy dx is less than 0. But what is happening there? So I want you to look at now the red one. So the red one is increasing up to there. But that portion, when you look at that portion, there you go. When you look at that portion, this one is actually, the dy dx is positive because it is above that x-axis there. Alright? So on this part, it is increasing. We can say that the dy dx, okay, the dy dx is greater than 0 because it is above there. Now, when you look at, for example, if from here up to there, we have said that it is decreasing. However, when you look at from this part, okay, up to this part here, because it is decreasing at that portion, when you look at the values of y, this blue part here is actually negative. Or the dy dx there is actually negative. So in this part where it is decreasing, the dy dx is less than 0. Alright? And look at it again. From here up to there, the curve, the red function is actually increasing again. But take a look. That is the blue graph here that is above the y, alright, sorry, above that x, above this horizontal line. And here the dy dx is greater than 0. Let me just erase that one. So this one, the dy dx is greater than 0. So basically, we can see here that if the derivative of the function is greater than 0, we can say that the function is increasing. If the derivative of the function is less than 0, then you can say that the function is decreasing. If the derivative, similarly in this one, the derivative of the function is greater than 0 at this part, then we can say that it is increasing. Okay? So that is our objective number 1. Using the first derivative, you need to identify whether the function is increasing and the function is decreasing. When can you say that it is increasing? If the dy dx is greater than 0. Let us put that one here as a summary. So to summarize that one, I will use this symbol for my dy dx because I need this space. So if the y prime is greater than 0, alright, then you can say that y is increasing. Y is increasing, INC. Now, if the y prime is less than 0, then you can say that the function y, which is the red one here, is decreasing. And what is something amazing there is that at this point where dy dx is greater than is equal to 0, look at that. What is that one? That is actually the stationary point. So therefore, if your y prime is equal to 0, then you have the stationary point. Okay? We can say that the point is stationary if y prime is equal to 0. In your examination, you will be asked, hey, to what values of x does the function increases? To what values of x does the function decreases? And to what values of x does the function have stationary points? So in this specific example, when you look at this, try to look at that. So let me just clean this one properly, because now it looks a little bit ugly. So let me erase this one. Well, the summary is here. Okay? So I want you to look at these two lines here. I don't know if that's visible. So as you can see, there is, let me pull this one out. Just bring it in. Okay. So here, as you can see, at this specific value, where dy dx is equal to 0, the blue curves are dy dx, you have there the stationary point. And what is the value there? It says here it's 1.54. Alright? I'm sorry for the number. It's just like an approximation. So it's 1.54 there. And then this one here is this 1.54. And this is negative 0.23, right? So therefore, when you look at the question, so let me just write it down. So this point there is negative 0.23. This point there is 1.54 or 1.55, right? So the values of x, where the y is increasing, is actually from here up to this value. Alright? So we can say that x is less than, but let me just move it here. X is less than negative 0.23. Well, the value of, it's the other way around. So this one should be, increasing, so this part here. So that is now x is less than negative 0.23. So meaning, towards this value here, alright, this curve is always increasing. It's going up. Now, it is decreasing from x is greater than negative 0.23, but less than 1.54, we can say that your y is decreasing. At the y prime is equal to 0, at that case, if x is equal to 0, at x is equal to negative 0.23, okay, and at x is equal to 1.54, these two values, okay, will give you the stationary points. They're actually the stationary points. These are the values of x, and your y prime is equal to 0 according to this graph. So that is actually the behavior of the curve. Now, I want you to look at that at this point here, alright, that is the x is equal to negative 0.23, x is equal to negative 0.23. When you compute the y there, it will give you 2.11. And at this point, 1.54, when you compute the y there, it will give you negative 0.63. Alright? So, this point here, as you can see, it's actually above, and the opening is downward. So we can say that this stationary point, the nature of this stationary point is maximum. Okay? Again, this stationary point is maximum. And this stationary point here is minimum. So again, the stationary points, when you say nature of the stationary points, that is this one. Okay? When you say nature of the stationary points, it's either maximum or minimum. So in your exam, you'll be asked find the stationary points of the functions and hence determine whether it is minimum or maximum, or hence determine its nature of roots. Okay? So, there you go. Now, however, when you determine the nature of roots, there are only two ways to do it. Okay? The first one is using the first derivative test, and the second one is using the second derivative test. Now, let's try to graph the second derivative test. Again, I'll just put it here. The stationary points could either be max or could either be minimum. Alright? Sorry, before I put into the second derivative test, let's try to look at, because we're already here, let's try to look at the first derivative test. Let's look at this point here, this maximum point. Okay? What can you say? As you can see at this point here, this blue portion is above the line, above this line here. So we see that y prime is greater than 0. And this one is below the line, below this line, this curve is below the line. So we can say that y prime is less than 0. Okay? Then what can you say about it? This one means increasing. This one means decreasing. Okay? So in short, if something is increasing and then all of a sudden it decreases after this point, after this stationary point, then we can say that this point is maximum. So from y prime is greater than 0, changes to y prime is less than 0, then we can say that this stationary point is maximum. Otherwise, if for example, when you look at this point, this blue curve here, again, is below this one, okay, below this line. So it means y prime is less than 0. So here y prime is less than 0. Then right after that, the y prime is greater than 0. So what is the changes in the curve? So here it is increasing. It is increasing at this portion, and then all of a sudden decreasing. I want you to look at this portion. Okay? By the way, this one is just this tip. Only this tip here. That this portion is increasing. That's the stationary point. This portion is decreasing. Okay? Then you can say that this one is maximum. Now, this portion here, let's try to take only this portion here. Alright? And that portion, this portion of the curve, is actually this one. Okay? And we can see that here it is decreasing with this portion, or we can say that y prime is less than 0, and it is increasing at this portion, or we can say that y prime is greater than 0, then this stationary point is actually minimum. Okay? So again, and that one is what we call as the first derivative test. So what is again the first derivative test? The first derivative test tells you that if the derivative is changing from positive to negative, the stationary point is maximum. Or if the curve is decreasing, increasing because it's greater than 0, increasing, then decreases after the stationary point, then we can say that that stationary point is maximum. If, for example, this part here is decreasing, then stationary point, then increasing, then we can say that this stationary point is minimum. Okay? So I will cut this video here because I think it's a bit long now. And then later on, the second part of this video is that we will try to look at more into the second derivative test. Thank you.